All right. So, all right. So, hello everyone. I think we should get started to not, endanger the tight schedule that you have today, and because of course we're all very curious to hear the talk. So, yeah, my name is Andreas Bulling. I'm one of the co-directors of the ELLIS unit Stuttgart, and it's my great pleasure to welcome Raquel Fernandez with us today from the University of Amsterdam. And I will not take too much of your time because we really want to hear from Raquel what she's been working on. But just to give you a few highlights of her career, so she's a full professor of computational linguistics at Amsterdam. And you have actually studied language and cognitive science in Barcelona initially, then went on to do a PhD in natural language processing in King's College in London, so you went to the UK. Afterwards, then you've been also in Germany, in Potsdam for some time, in Stanford as well. And yeah, then essentially you came back to Europe, I understand, and now you're in Amsterdam since quite a few years. Of course, numerous prestigious fellowships and awards in the career. I think most importantly, recently European Research Council Consolidator Grant. Was it 2 years ago?
No, already 4 years ago.
4 years ago already. Time is passing quickly. And of course, you're also an ELLIS Fellow. And that's also, of course, the reason why she's here today, because we invite distinguished ELLIS Fellows to give a talk in our lecture series. And yeah, with this, I would, as I said, already leave the stage to you and not waste any more time, because we really want to hear about your research on LLMs. So thank you very much for being here, and we're looking forward to your talk.
Thank you. Thanks a lot. Thanks a lot for the kind introduction and for the invitation. More generally, I'm really glad to be here to see some known faces and some... The mic is not working right here? No? Well, I think this mic is just for recording purposes. I'll try to speak a bit up, and if it doesn't work, then let me know and we'll try to fix it, right? Yeah, so I was saying that I'm happy to be here. I see that I know some of you, many new faces as well. So yeah, it's really a pleasure, and I hope to have the chance to talk to several of you afterwards. So yeah, I'm happy to give you some more details about some things that I will present very briefly in the talk, and to talk about other things and your own work as well. So today for this talk, I will be talking about multimodal and conversational grounding. So multimodal grounding and conversational grounding in relation to the type of LLMs that we are using now as main technology. Okay. So these LLMs that we are all using in many fields, we know that they are being used in fields that go beyond NLP, which is where they have emerged, where they were developed. Right? They have become relevant in many fields that are powered by machine learning, for example, robotics, automated reasoning, and others as well. But interestingly, they are being used not only on these fields that are more machine learning based, so what would be the ELLIS umbrella of things, but also in the humanities and in the social sciences, in media studies. For example, I have a colleague, Roberto Cerino, who is a social scientist who is using LLMs for his research on political opinion, right? So he developed this tool as a polling tool for US election. I think that the prediction was more or less in the direction that things seem to be going, right, for better or worse. But yeah, many of you may have also examples of colleagues that are using LLMs in this way in the humanities and the social sciences. And I think that the appeal of being able to use this technology, of using this technology in this kind of fields, is the fact that it is so convenient to just prompt an LLM and to get back something in plain natural language that is so fluent and so on, right? So this has sparked a lot of different applications in many fields that are quite beyond machine learning, right? And so indeed, it is the case that with this kind of language technologies, with large language models, we have tools that are exceptionally good at producing fluent language. So I don't know if you're familiar, I hope this is not too small, with this paper that came up actually early this year by Kyle Mahobald and Anya Ivanova and others. This is from the F. Fedorenko group, that makes a distinction between formal and functional linguistic competences, right, of humans, and also of LLMs. And then they point out that yes, that LLMs are very are really good at this idea of formal language competence. What does it mean? So that they are great at generating text that is fluent, that it's grammatically correct, that it's at least apparently meaningful, and as we know, it may be often indistinguishable from human text, right? So these are abilities that are out there. So this kind of formal competence of language seems to be mastered by this kind of technologies like large language models. But we may still wonder whether language models are good at using language, right? Not just as having this formal language competence, but at actually using language. I think that the authors of this paper may argue that maybe we should not expect them to be, because they have a whole argument on separation between functional and formal competences, and they argue that the language models may be good only at formal competences. But the fact is that we are using them in a lot of language use situations, right? So I think that the question is still relevant of asking whether language models are good at actually using language. And what do I mean by using language? Well, I mean highlighting the fact that language is for communication, right? It's really for exchanging ideas between agents, between humans typically, right? It is for communicating ideas, not just something that has to do with how things are formulated, right? So language is actually for communication, for interacting, for exchanging ideas. So language is a form of joint action, right? So a form of being able to coordinate, to do things together. That's what I would argue, right? Of course, other people that study language from a different perspective may consider that what's interesting about language is something else. Maybe, I don't know, it's syntactic structure, for example, right? I'm not going to necessarily argue against that, but from my perspective, what I find interesting about language, it's the fact that it is a form of joint action and that it is useful for communication, right? So it's not only about this more formal aspect of language. At least that's what I find interesting. And there is no one better to argue for this kind of view than Herb Clark, perhaps, if you are familiar with his work. There is this quote, which I believe has been used many times in the history of talks, but I still love it. And Herb is telling us the common misconception is that language has to do with words and what they mean. Well, it doesn't. It has primarily to do with people and what they mean, right? So what does he mean here? So basically that what matters about language is really what are the intentions of the speakers that are using that language. So not just what the words actually may mean in a formal context or whether something is grammatical, fluent, etc. Right? So using language, according to this view, involve recognizing speaker intentions. So some notions like speech acts or dialogue acts aim to capture this idea. What's the intent behind what is being said? And the fact that so using language also involves constantly building and monitoring common ground. So what's common ground? The information that we assume that we share with our interlocutors, right? And this is crucial to be able to monitor what information we share for being able to provide, to make contributions in a conversation that are relevant and so on, right? And how do we do this monitoring? Well, to a great extent, through conversational grounding. Conversational grounding strategies, for example, asking clarification questions, being able to acknowledge that we are in sync or to signal that there is some miscommunication, right? So this is what's called conversational grounding. And these kind of strategies are very critical, right? And so this view also emphasizes the fact that the same surface form of an utterance may really mean very different things in very different contexts, depending on the context, actually, but also on the speaker intentions, right? And one example that is pointed out in this paper by Clegg and Schubert is this phrase here. If we utter something like "to please," this may be very different depending, the meaning that we can extract, the contribution that we can extract from this may be very different depending on whether we are at the cinema, at the ticket office of cinema, where it may be understood as 2 tickets for Barbie, for example, or if we are in a lift, in an elevator, where this may mean push the button to the 2nd floor, right? So the same surface form, different types of meaning, different types of intentions. This is quite underspecified, that's true. Typically, the context will provide the right type of meaning. If not, we have these grounding strategies that would allow us to just make sure that we are in sync, because we can communicate, we can ask questions, we can we can coordinate and ask if necessary. Okay. All right. So with this kind of introduction, let me tell you a little bit what I plan to talk about today to you. So I would like to spend part of this talk discussing language models' potential for conversational grounding, pointing out some work by others and some work by us as well. Then this initial part will be related just to models that are trained on language only. And then I would like to move to visually grounded language models, so models that are trained not only on text, but also using visual information, right? And then at the end, if I still have time, I hope so, I want to just mention something that is also multimodal in the sense of exploiting vision and language, but in face-to-face communication, because this initial part is more abstract, not so much on face-to-face communication. And this is just some recent work that I'm excited about, and I want to mention it to you in case that it speaks to any of you and you're interested. Okay, so that's the plan. If there are some clarification questions along the way, then feel free to ask. I would prefer maybe not to go too deep into some things. I will mention several pieces of work and not with a lot of detail, but I'm very happy to discuss any of these in more detail later on if there is interest. All right, so I was saying before, well, what should matter about language use is to extract speaker intentions, to extract the intentions that are behind a certain utterance, and that this is connected to what are speech acts or dialogue acts, right? And one common way to think about speech acts is as constraining the set of follow-ups within the discourse. Right? If we are in a particular situation, in a particular discourse situation, dialogue situation, a dialogue act, a certain statement, a question, a command, etc., is in part defined by how it constrains what is relevant at a certain point in the discourse. Okay? So we can also say that to comprehend the speech act, like the intention behind a given utterance, is to have certain expectations about what may come next. This is critical for dialogue act understanding. This is the main idea behind all the philosophy of language in this domain. So consider, for example, this initial dialogue. Can you help me, please? Sure, if I can. I want to send this small parcel to Canada. There are several possible continuations that are available here. This set is somewhat restricted, but is also rather broad, right? So this is a specific example that comes from this data set, daily dialogue. And some possible combinations, you have them here. So you have questions, some statements. So what do you want me to do? To whom? Or it takes 10 to 14 working days to reach. Okay, can I get the address? That's another possibility. Or do you want to send it by sea or air? And there are many more, right? So there is some variation in this set of possibilities. And the amount of variation that we can find here on what can be said, right, on the sort of next possible continuations in terms of dialogue act, is determined by the communicative situation, right, in which kind of communicative task we are, right? So typically in dialogue, we have very open-ended situations where many things are possible. We can continue a dialogue in many different ways because also the intentions and the goals of the two speakers can be quite varied. So it's a very open-ended type of communicative situations, but other type of communicative situations where we use language might restrict this variability, at least in terms of what to say next, right? For example, if we are in a machine translation communicative situation, right? Let's forget about machine. In a translation communicative situation where it is clear that the goal of what comes next is to provide a translation of what has been given as input, then the what is very restricted, right? So the context is restricted, the next action is restricted, but still there can be quite some variation on the surface form of how this next action can be expressed, right? So in this particular example, this phrase in English can be translated in different ways in German, and you might be able to appreciate this much better than I am. Okay, so there is also this variation at the level of the surface form. And yeah, so it's important to figure out, to realize that the amount of variability and open-endedness really depends on the communicative situation. So connecting to this, in some work that we published last year that was led by Mario and Joris, two students and also some colleagues like Wilker Assis and Barbara Planck, we focused on studying the type of variation that we find in different NLP tasks, in different communicative tasks, right? So so analyzing the variation that is found in the generation of LLMs. So I'll give you the gist of this kind of this work. So this work relies on this idea. So at its core, a language model is essentially a probability distribution over word sequences given a context, right? I know that there is also a decoding algorithm, but let me stay just with this core, with the generative power of the language models. So we can say that, that the language model just captures a certain probability distribution over sequences of sentences, right? So what we are asking in this work is this representation of the model's generative potential that can also be considered as a representation of the model's uncertainty in certain views, right? So is this representation of the model's uncertainty in compliance with the variability that we observe in human production variability, right? So in human production, sorry, right? So there is a certain variability in human production. I just gave you two examples, one in the context of dialogue, one in the context of a different type of task translation. This variability can be of different types. And one question that we think is interesting is to check whether language models may capture this variability, right? You can think of this as a possible way of, as a dimension along which you may want to evaluate language models, right? We could discuss how much we want language models to match the distribution of variability in humans, because that might be different depending on your goals and depending on the application that you have in mind. But it seems to be a relevant dimension. So after all, we use these language models for doing tasks that are for us, for humans, right? So this is the question that we are investigating here. So to do this, to operationalize this question, we are going to measure, what we do is to measure the pairwise distance between a sample of generations. We take a sample of generations from the model and a sample of productions from the human population, right? So we need some data sets that offer a variety of next continuations, which is something, unfortunately, sometimes not so easy to achieve, but there are a few data sets where we have this, right? So we sample, given a context, right? So given a context here, we sample a set of productions from the model, and then we do the same from the human population. We sample a set of productions from the human population given the same context, and then we just measure pairwise similarity between these productions, right? And what kind of similarity? I mean, along which dimension? This is something that would depend on what is your interest. In our case here, we just propose three simple measures, for example, semantic similarity, where we are just using the sentence embeddings of this production. Also, another one that we mentioned that I will not talk about would be just lexical similarity, just using n-grams or bigrams as the surface form. And in this case, we are also using a sort of proxy for structural similarity, part of speech tags, like n-grams of part of speech tags. But you could think of defining your own similarity measure depending on what you want to measure, okay? So then you compute variation with this kind of pairwise similarity measure for the two populations, for the generations of the model and for the generation of the humans, and then you compare these two distributions with some statistical divergence measure to figure out how much they diverge, if at all, right? So this is the gist of the methodology in this paper, and I just want to give you an upshot of the results that we get. So here on the left, you see the results for humans, for the human population. We are looking at 4 different tasks. Open dialogue, as I already mentioned, translation, but also text simplification and story generation, right? And you can see that the amount of variation given a certain context really is quite different depending on the task. I think this is very intuitive, right? But I personally am still finding it quite nice to see this empirical confirmation of what we expected. Yes?
Can I maybe ask a quick clarification question? So are we looking at the level of generating word by word, or like utterance by
No, so we are generating word by word, but the comparison is done at the utterance level. Yeah, so it's at the utterance level, and what I'm showing you here is semantic variability. So this is the pairwise similarity of the sentence embeddings. Yeah, so we can see that in the more open-ended tasks, like story generation and open dialogue, the green and red over there is much more variation in what can connect. I think this is very intuitive, and this is quite different for text simplification and translation, where in principle the meaning of what needs to connect is quite defined, right? So you should not deviate too much from this, and then you can really see this here very, very clearly. Okay, right. So depending on the communicative task, the amount of variation that we find is quite different. And also the question that we asked was, is this variation potential, is this matched by what we see in the generation of language models given the same context? And that's expressed in this plot here. So this plot expresses divergence of the two distributions. And as you can see, well, so if the results are centered on 0, then that would mean no variation, no divergence. To the left, that would be underestimation of the variation, so less variation that we see in the human productions, and deviations to the right on the positive side, that would be overestimation, so more varied output, right? And yeah, so what we can see is that I would say roughly centered on the 0, but for example, for translation, we see that there is underestimation, so the models, even though that's one of the most less open-ended, right, tasks, the models actually tend to be less diverse. So there is a tendency for just reusing the same type of phrases when sampling different generations, rather than being more varied as we see for humans. While in dialogue, it is the opposite. So again, one of the most open-ended tasks, the model actually is even more open-ended. I don't have examples here, but basically sometimes what happens is that some remarks that look a bit off the mark, right? So that, like, there is outputting some things at the end that really are not so coherent, right? So this open-endedness comes from somehow not exploiting coherence so well, right? I should say, so I will not say much more about this work. This was done in the first half of 2023, this work. So we were using models that were not as powerful and as advanced as we have now, right? So we didn't have Llama or something like this. I think it would be quite useful to replicate these results with more powerful models. We might see slightly different results. But what I want to point out from this, what I want to highlight is just that, okay, what I just said. So LMs sometimes overestimate the variability in open-ended tasks and sometimes underestimate it in more constrained tasks. But I would say overall, the fit is reasonable, and I think this should be replicated also with newer models, and also with not only newer models but also newer training methods, right? So there is also experiments in the paper where we check the effect of the decoding algorithm, right, of the sample algorithm, because you may be wondering, well, but that probably has a strong effect. Actually, in these experiments, it did not have strong effect. So it did not change the general patterns, the type of decoding algorithm, or the temperature parameter as well. That did not change the results very much, but there is a full section on this in the paper. So if you are interested, you are very welcome to take a look. Now, I introduce all this because I want to go back to my story from the beginning, if you're still kind of following, right? So I mentioned that, but before that, jumping from one thing, but before that, I just wanted to plug something in case that there is also interest, that this approach of looking at the variability and at the possible sampling generations from language models is also something that we have been exploiting to define a measure of processing effort. So this is from a more computational psycholinguistics point of view, right? So to define a measure that is kind of complementing the classical surprisal measure for measuring processing effort, right? So it's just a bit related to this methodology. I just put it here because if some of you are interested in psycholinguistic work, then I would invite you to check these papers where this methodology slightly changed, but it's really at the core. It's what made us thinking about this work is employed here. So if you're interested in this direction, these are some pointers that you may want to explore. Now, yes, going back to my previous story, right? I was saying that that being able to understand what are the intentions of a certain dialogue of an act has to do with realizing what is the set of possible continuations, right? So how that dialogue act is constraining the future context of what comes next in any communicative situation, right? And from this work that I just presented, we could conclude that, okay, that this set of possible continuations is maybe, we could debate, but it's reasonably captured by current models. We could conclude that that is the case. So now we may ask, okay, but the fact that this happens at this sort of high-level analysis of capturing the range of things that can come next, does this mean that actually models are able to infer communicative intent, right? I think definitely not. So we should not take these kind of strong conclusions for this kind of work. This still might be useful for this line of thinking. Maybe this is a necessary condition, but certainly is not a sufficient condition for concluding that models are able to infer communicative intent, right? And this connects, at least in my mind, this connected to some work that Jacob Andreas published 2 years ago. And since then, there might have been other similar work. Well, that was very much a paper of its time. But I don't know if you're familiar with this work. In this work, Andreas is arguing that, well, he's discussing to what extent language models, so there was a moment with a lot of discussion on whether they capture meaning, etc., right, with the Bender and Collar paper and so on. So it's a bit of follow-up on that. So he's argued to what extent the language models are able to capture the intentions and the beliefs of speakers and so on. And here he kind of concludes that they seem to simulate agent behavior to some extent, so that when you put them in a certain context, when you condition the generation on a certain context, then because they respond in a coherent way, this seems to provide a kind of simulation of capturing whatever implicit beliefs and intents are present at the moment, right? So through their training by a next word prediction, he concludes they may infer in the intention of the agent to some extent, given a context, right? I think, okay, we can debate. This is more a philosophical point, perhaps, right? So if that's the case, then maybe that's a good starting point for language use as being beyond formal language competence, as I was mentioning at the beginning. But it remains to be seen how to go from here, right? So at that point in 2002, the language models that were being 2022, don't get me wrong, the language models that were available at the time. So there was still the methodologies of instruction tuning and even RLHF maybe were already starting. I'm not sure, actually, maybe it was more 2000, well, at the end of that year. But certainly after that, this has become much more standard and much more prominent, right? So using instruction tuning, reinforcement language with human feedback, or also type of trainings like direct preference optimization, right, where the models are faced with preferences on what are best continuations. So you could say, well, if anything, with the adoption of these methods, maybe the idea of having language models as agents, if anything, should have improved, right? Because they have more information not only on next word prediction, but on what are plausible and relevant continuations in a more communicative context, right? Because we have an instruction and a continuation. We may have an instruction and two possibilities, and we tell the model which is preferred over the other, right? So we could think that maybe this is improving this more language use facets of language models over the formal language competence, right? But it doesn't look that promising for now. There is quite some work in one direction or the other. I want to highlight specifically one paper that I enjoyed reading very much this year, which points out that, well, so as I was saying at the beginning, humans are really good at exploiting conversational mechanisms for building common ground and for making sure that we are in sync, right? For example, at acknowledging and asking clarification questions, right? But while humans do that, the fact that we train our models with instruction following seems to lead to models that just directly act on commands, right? And don't exploit these conversational grounding strategies, right? So they tend to have a bias towards assuming that there is grounding, that you are on the same page with the user, right? So the training regimes just lead them to have this conversational grounding bias, assuming that there is grounding. And the paper that I was mentioning is this one, Grounding Gaps in Language Model Generation. I think it's a really neat piece of work. And what it shows is that the large language models use significantly fewer grounding acts than humans do, right, in terms of acknowledgements, clarification questions, and they are focusing on domains that are particularly sensitive. I think there is, now I don't recall, but specific domains. A domain related to mental health, perhaps, and a couple of others I don't recall right now. Probably impossible to read the small example here, right? But so the paper shows that language models use significantly fewer grounding acts than humans, and importantly, that additionally training them with supervised fine-tuning, like with instruction supervised fine-tuning, or also with additional DPO, actually does not lead to the intended effect. So that these kind of training mechanisms are not favoring the adoption of conversational grounding strategies, right? And that in fact for DPO, this may even be detrimental. So you can see here just the graph on how these different types of conversational grounding acts, like acknowledgements, follow-ups, clarification, actually decrease if you try to favor them by this kind of training regimes. So it looks like, that even the most current metrics, the most current training methods are really not favoring what we would like for having language models that are more language users, right? So we may argue, we may ask, so what are we missing? I'm not going to fully answer this question because I think it's going to be a while until we kind of figure out exactly what we are missing. But one of the avenues that also has been around for a long time about what may be missing from these large language models is that they are trained only on text, right? So this is a long-standing argument on the fact that well, to be able to use language for real, particularly for communication, would require having access to a lot of other types of information. And one of them, obviously, is perceptual information, visual information, and others might be more socially oriented type of information. I'm just quoting this here from an essay in 2022 from Jacob Browning and Jan LeCun, but obviously many people have made this argument, right? So now focusing more on visually grounding information as a type of information that might be missing from language models is obviously not the only one, right? So this has been also extensively argued from the cognitive sciences, right? So according to theories of embodied cognition, then we know that that human conceptual knowledge and in connection to human linguistic knowledge as well is grounded in our sensory motor experience, right? Not only perceptual, like vision, but other senses as well, like hearing or touching or action, right? So the idea of training models that have access to these additional types of information, in principle, so tries to build on this to see whether we may have richer models that learn richer representations and that are able to act in the world in a more natural way, right? Of course, there is also a more applied angle to this. There are just many interesting tasks that are multimodal and that we want to be able to handle, right? But there is also this theoretical motivation on meaning representations presumably being grounded in our sensors and in our sensory information and in our perception. So questions that have been asked are, for example, this, like whether visually grounded models have some kind of advantage over text-only models, right? And this advantage could be, for example, in terms of language learning, in terms of the type of representations that are being learned. So we've done quite some work on this, and I think some of you definitely also have done quite a lot of work on this, right? So one of the pieces of work that we did a few years ago already, together with Sandro Pezzelle and Ece Takmas, our PhD student, was to look at the lexical representations that some of these models learned, right? Some models that were present back in 2021, so a little bit different from the ones that are present now. And so something that is known that had already in a way, been checked for earlier models, more distributional models, right? But here we were checking the transformer models that were coming up in 2021, is that models that are visually grounded tend to learn representations of at least concrete nouns that are closer to the representations that humans have, right? And in this case, we were checking this by investigating how well the representations of the models correlated with human similarity judgments of concepts, right? So you have similarity judgments between concepts. The humans have judged this similarity, and you can correlate this with the cosine similarity of the word embeddings that you extract from the model. That's a classic methodology. So what we see here is that when we do this correlation for pairs of words that tend to be more concrete, for example, donut or bike, right? So these are things that are more concrete, that may be graspable, and so on. Then these were the visually grounded models that we were using at the time. They obtain a higher correlation. So the representations that are being learned for this kind of works are more aligned with the conceptual knowledge that you can see in humans. While a model, which was BERT at the time, that has only access to text, actually has lower correlation, right? But this is not the case across the board, because when you take a data set that contains more abstract words, like, for example, freedom, dreams, and so on, then you see that, in fact, adding visual information does not give you any advantage. So, in fact, just models, the representations of these words that have been learned only from text are more aligned to the kind of conceptual representations that we have, right? So I think that this kind of result has been replicated many times. In this case, this was done for these models that were new at the time, right? So yeah, so visual information can help and be important in certain situations. It doesn't mean that is always absolutely necessary and critical, right? Another piece of information, also in this line of inquiry, right? Whether visually grounded models learn better, richer, more human-aligned representations than non-visually grounded models, where in this paper, the authors show that that the advantage of visually grounded models may be on the efficient side of things, right? So not so much that the representations are richer, but that having visual information may just make learning more effective, more efficient, and particularly when the training data is limited, right? So here the main argument is that, so that if we restrict the training data, making it more similar, still very different, but more similar to scenarios related to language acquisition, to how children learn language, then we see an efficiency advantage for having visual grounding over learning only from text. All right, but so some visual and language models, some visual information does give us some kind of advantage, be it in terms of efficiency, or be it in terms of having richer representations for concrete nouns, right? But this does not mean necessarily that these models learn representations that are very cognitively plausible, whatever that means, right? So, for instance, in a work that we published early this year, also led by Sandro and led by Eche, and also in collaboration with Sandro, we checked whether the representations that I learned by CLIP in this case, by the Visional Language Model CLIP, actually whether we can decode from these representations different measures of how humans process images, right? So, like, for example, how long will take a human to start describing an image, which may be due to several features of the image, between others, right? With what kind of concepts they will start to describe an image, what kind of fixations they will display on the image by using eye tracking data, right? So because the variation in these kind of measures, like the onset of speech, the scan path, and so on, the variation between humans on these kind of features presumably comes to some extent from some features of the image, right? So if the image is, for example, difficult to process, you may expect that there is a lot of variation on the fixations or things of this sort. Presumably comes from features of the image. We thought that perhaps the models that are learning visual representations from this image may capture some of this variation, right? That there could be the potential for decoding some of this information from the visual representations that are learned by the models. But our results here were not very positive. So basically, many of these kind of processing measures from humans, like the humans processing the image, were not so easily decodable or not very reliably decodable from the model representations, right? I'm not giving a very structured presentation of this work here. Again, if you're interested, we can chat about it afterwards, right? So it's well known also in terms of how much we gain from visual grounding and so on, that so mostly I talked about lexical knowledge in the previous parts, not so much less work, but anyway. But it's well known that when it comes to learning compositionality, right, compositionality grounded in visual scenes, that things can get a little bit more tricky, right? And that models like CLIP, for example, which are learned just, which are trained just to align textual descriptions with images, often lend representations that are a little bit like back of words, right? Where compositionality is not captured in the best possible way, right? So to test this, we developed last year a benchmark data set. There are quite a few data sets that target similar things, right? Where we test models with different types of constructions, very similar, very simple constructions, like for example, active-passive. And there are a couple of other constructions that we took inspiration from how children are being tested in their language abilities, like preschool children, right? And active-passive voice is one of these constructions for assessing the language abilities of children, right? So in this case, you have an image and then 4 sentences that use basically the same words, the same content words, right? But put together in different constructions, such as the meaning is different, right? So 2 of these sentences are true, given this image, and 2 of these sentences are false. All the sentences use the same context. So you would expect that models would be able to distinguish between what is true and what is false here, right? If they have not only reliable lexical knowledge, but also compositional understanding of the image, right? Well, at the time when we published this, the models that we tested, they were at chance level, which was really disappointing because, I mean, this seems to be a very easy task, right? But they really were not able, definitely CLIP was not able to do this task. Right? And other models that we tested at the time also were not able to do this task. Around the same time, several benchmarks that tried to also test the compositional understanding also came up. Some of these might be familiar to you, and they all got these results that the knowledge was not so sophisticated. Tell me.
Is there a way to disentangle or to answer whether this is an inability of already the language component to distinguish between those, or whether it's specifically the mapping of the language onto the visual?
Yeah, I think that's a good question. That's that how to go with finding out where the problems are, I think is going to depend on the architecture of the model, right? But these are the things that we would like to know, right? So is it something? Yeah. So my personal view is that it's something to do with the mapping of the 2 modalities, right? Yeah. So I think, yeah, it's somehow in the mapping of the 2 modalities, but I think that sometimes the information that comes from the visual component is not structured enough, right? So what you would like is that the kind of that the language supervision helps you to provide this additional structure. But then I think that just contrastive learning regimes like CLIP are not favoring this kind of thing, right? So this, as I will mention in the next slide, many of these things have been solved to some extent with the generative vision and language models. But still, we don't understand very well why it has been solved, right? So I think that understanding where the problems are coming from is an open question. So yeah, in line with the same issues of compositionality, we've also seen that it is rather easy to fool models by just providing adversarial descriptions that maybe are very grounded in the visual scene, but that where the compositionality is wrong or where the plausibility is wrong. So in this work, for example, we were focusing on advertisements, like image-based advertisements. This task has many issues, so anyway, it has many issues, but this is the task that we explored at the time, right? So I don't know if any of you is familiar with this. So this is a data set that has visual advertisements, and there is an annotation of what are possible explanations for what's the message that the advertisement is conveying, right? Here, right, so the top one would be an explanation for this ad, a possible explanation of what the ad is meant to convey. So I should go to this burger place, I guess, because not only does their food taste great, but it also looks good. Well, explanations of this kind. Basically, this work just shows that if you provide candidate explanations that are negative explanations, but that are very grounded because entities that are present in the image are mentioned, or because maybe text that is superposed on the image is also mentioned, then the models are very easily fooled, right? So that the underlying compositionality is actually not captured. I think that I don't know if Karina maybe has done some work with some hard negatives that, right? So maybe not on this task. But basically, the upshot is the same, that the models are not that strong on this compositional aspect. Now, as I was saying, some of these issues, some of these problems seems to have been to some extent resolved or alleviated by the newer generative vision and language models. Understanding exactly why they are alleviated by these models, I think, is still not something that is not very well known, right? But yeah, so definitely the works that I presented are already 1 or 2 years old, and things are changing very rapidly. But one aspect that perhaps has not been investigated so deeply is actually the problem of ambiguity, right? So beyond compositionality or lexical knowledge, ambiguity is another factor that, well, another property that is also very prevalent in language, right? And that we may want our models to be robust to this ambiguity, or to have behavior that more or less matches human behavior, right? So yeah, ambiguity under specification is something that we use regularly in language. It's a property that is part of language. It's not a bug, but really a property of language that has been pointed out repeatedly. And when we have utterances that are ambiguous, underspecified, like the very underspecified one that you have here, they put the flowers there where we may have the ictic pronouns or other types of pronouns, but generally, I mean, ambiguity may come from everywhere, right? It may come from having multiple senses of words, but also having this kind of under-specification. So when there is ambiguity under specification, often the context just helps us to resolve it. But if not, as I was saying from the beginning, then we still have our conversational strategies, right? So we can always use conversational grounding strategies for trying to stay in sync. So if something is too ambiguous to be resolved, then we may ask clarification questions, or we may ask other type of conversational strategies to stay in sync, right? But given the sort of results that I've outlined up to now, it's not clear that models are going to deal that well with this type of phenomenon, right? So one type of ambiguity in the context of vision and language is referential ambiguity, where there might be different entities that are candidates for some phrase, like for example here, these beans. Hope that you can see this despite the light. Right, so if I ask you something like what color is the trash bin, and there are 2 possible entities that match the description trash bin, then that's referential ambiguity. Or that one there, give my greetings to the professor. If they are two individuals here, that could be the professor. That's also there is also referential ambiguity, right? And these kind of questions maybe look a bit unnatural to you, I'm not sure, but they could arise naturally for different reasons, right? So maybe the participants have unequal access to the visual context. Maybe, in fact, actually this question here comes from a data set of visually impaired people, right? When we're asking questions about certain a visual situation, right? So there might be different reasons for asking this kind of questions. Maybe there are some mismatches in the dialogue history that lead to these questions, etc., right? And not recognizing that there is ambiguity in this kind of questions could have serious consequences, not only because it may lead to misunderstandings that may not get resolved at all, but also because in some situations like that one there, maybe not recognizing this possible ambiguity could lead to just reinforcing some stereotypes, for example, right? Depending on who you pick as the possible candidate for being the professor that is being referred to here, right? So I think in general there are clear reasons for wanting to have models that are able to recognize that there is ambiguity, right? So in the last couple of months, we started to investigate this question, right? The more general question, do multimodal models respond to, how do they respond to ambiguous questions? Are they able to recognize ambiguity? So is it satisfactory, the way in which they respond to these possible questions that they may be posed? So this is a project led by Alberto Testoni, who's a postdoc in my group, and in collaboration also with Barbara Planck in Munich. So this is not published yet, I put it here. Soon it will be in archive. I think sometime this year it will be in archive. So I will just give you the gist of what this work is about. There are quite some aspects that have to do with the concrete aspects of the methodology that I will not go so much into. But well, again, you can ask me questions later if you have them. So, so we've been creating a data set of referentially ambiguous questions about images. So questions that are images with questions that are ambiguous about these images, and we have two settings. In all cases, the images have been carefully selected such that there are several multiple entities that could be candidates for the phrases that appear in the question, right? And such that there are no big differences with respect to the area that they occupy on the screen, that they are not particularly salient, etc., right? So the first setting of this data set includes images from MS Coco, and they are paired with handcrafted ambiguous questions like this one here. What color is the bus here, where there are 3 buses? Or what does the sign say? Here you can really not see it, but these signs that are hanging from this, they have some stuff written on them. All right, so this is the first setting. And the second setting is one where we have actually automatically generated the images using the ELLIS. And these images are also paired with handcrafted ambiguous questions. These images generated always include 2 people, so they are on people. And they also include a certain adjective, right? So we are here, in this case, we are interested in social stereotypes. And we are using 3 categories of stereotypes: gender, disability status, and ethnicity. So we will always have 2 people that will differ along one of these dimensions. And then the difference with respect to the previous setting that I mentioned is that here we always introduce an adjective that is well motivated, how we choose its adjective, given work that has been done on stereotypes elsewhere. That is an adjective that cannot readily be grounded on visual information, such as assertive or sweet, as attributed to a person. So you cannot immediately see this visually, presumably, right? And that if you use it to as a sort of disambiguating cue, then it could possibly reflect stereotypical assumptions, right? So that's how these adjectives like assertive here or sweet have been chosen to create these questions about these ambiguous questions about the images, okay? So these are the 2 settings that we have. So we may wonder, how should one person or model react to such questions? Questions like, what color is the trash bin when you see this kind of images, right? What are possible answers to these questions? Well, I think that one possibility is to actually signal that there is ambiguity, right? And there are different ways in which you can do that, right? So perhaps we can just, well, I think maybe the most natural thing perhaps is to ask a question, right? So to use grounding strategies, conversational grounding strategies, for example, which one, right? That, of course, depends on whether you can assume that both speakers have access to the visual information, because if the other speaker doesn't, you would not ask which one, right? So it really depends, but definitely using conversational grounding strategies is one possibility. Another possibility could be to mention that there are several references so that you acknowledge the ambiguity in that way, right? Like, for example, there are two, a black one and a green one. That's a possibility. And these two strategies kind of acknowledge that there is ambiguity. Another possibility, perhaps, is that you can assume that there is one intended referent, right? So after all, the speaker is using a definite article, right? The definite article carries a presupposition that there is only one element that I'm referring to. So maybe you can assume that there is one intended referent, but perhaps you can use more information to indicate which one you are referring to. Like, for example, the bin on the left is black, right? And at least with this, you give information to your interlocutor that you are referring to a certain one, so that you give the chance to the interlocutor to correct you. Then use grounding strategies for correcting this mistake. That's a possibility, right? So I'm putting it as orange because this does not directly acknowledge the ambiguity, but it's not so bad.
Is it not almost a subset of the previous second bullet point?
Well, I mean, it's a subset in the sense of which entities are mentioned, but I'm not sure that this idea of subset points at something relevant. Or does it? What do you mean?
I feel like to be able to specify which bin the model needs to be aware that there are two.
Okay, that's a good point. And maybe, okay, maybe that makes sense. Maybe that makes sense. I guess that we would need to test this with humans. I should tell you, if you find that relevant, that for models, they tend to use this strategy even when there is no ambiguity. And I mean, yeah, I wonder why. I think that this maybe has to do with the training data, the fact that maybe the captions where they are trained on, they tend to be verbose or try to say as many features as possible, right? To say, yeah, but they tend to do this even when there are no entities, no multiple entities that could be candidates. I'm not saying that's a good thing. So actually, it's a good point. So if humans don't do it, then you could say that this is also a more indirect way of signal that there is ambiguity. Fair enough. Right? Well, another possibility that I think we would not maybe expect it in humans, but another possibility would be to just assume that there is one intended referent, again, taking strongly this cue about the presupposition of uniqueness, right? And nothing else, and no ado. So say, okay, which color is the trash bin? Green or black, right? Because it could be any of the two of them.
What is this assumption about the intended reference based on? Is it just random inflection?
Yeah, no, okay, yeah. So, I mean, I'm putting these options here also based on the results that we already have, right? So you could think about possibilities. The colors should give you an idea of how I consider them, right? So I think this is not a very, this is not a reaction that I would like to see. And I expect that it will be not common in humans, right? I mean, but if it happens, which it has happened, and indeed you have the question, well, how do you pick that reference? There must be some saliency that leads you to select one as the most likely, right? That's what you meant. Yeah, so there could be some saliency aspects that could lead you to that, right? But as we will see, for humans, this is very unlikely that they do that. At least with the images that we have in this data set, which have already been selected such that saliency is not an aspect that could easily disambiguate between the different candidates, right? Okay, so these are some possible, I mean, yeah, so I'm explaining this a little bit backwards, but yeah, so you might see other possibilities as well. So I'm putting here 3 possibilities that are the ones that we have observed in the data. And the color coding signals more or less how we are considering them, right? So the green types for us signal the ambiguity very directly. We think that they are more appropriate. The B ones still, they provide some elements that would allow you to resolve the possible misunderstanding. So maybe not as optimal, that can be discussed. Maybe for some situations it is, right? And finally, the last one that makes an assumption, given that here there is actual ambiguity, we think that this is potentially problematic because it can just let misunderstandings uncovered, right? So now, how do humans actually respond to these questions? So we have a small human study on this. So we have only 4 participants here that were asked to respond to both ambiguous and non-ambiguous questions, just so that they would not be exposed only to ambiguous questions. That would be a bit odd, right? But the results that I'm giving you here are just for the ambiguous questions. And as you can see, overwhelmingly, they do a signal that there is ambiguity. And half, roughly, they either would ask a clarification question, or they would just list the multiple possible entities that are candidates for the referring expression. Okay, and seldom they would also sometimes choose just one possible entity, either providing an explanation of which one they are choosing, or actually not. I'm giving you some examples on this. Right, so these are class A, asking a question, which of the 2 guys in the picture, or just listing, the car in the front is white, the second car is gray, and the last one is black. These are possible examples. Sometimes they do this that we were saying before. What color is the car? Well, the closest one is black. Okay, so it's kind of making an assumption of which one is the most likely that is being referred and mentioning which one they have chosen. And sometimes they actually, not very often, but sometimes they just pick one. Like, for instance, here, what color is the traffic light? It is red. For which reasons, I'm not sure. Maybe in this case, they didn't realize that there is a second light, which is not so visible, right? So there can be all sorts of reasons for this kind of mistake. Sometimes it does happen. But I think overwhelmingly here, the pattern is that people tend to signal that there is ambiguity and that they may use conversational grounding or just some listing of the strategies. Okay. So how do models actually respond then? Here's the patterns of the models. You have the human distribution at the bottom, which is the one that I just showed you before. And here the models that we had, actually we have now added at least one more model. I don't have it here. So we have a bunch of models that are open to some extent, like the versions of Lava at the top and the WebVL chat at the very top. And then a few proprietary models, Gemini and GPT-4o. And basically, I think the pattern that is very visible here is that the green part is more on the minority for the models, that there is a difference between the proprietary models and the open models, but that nevertheless, acknowledging the ambiguity is not very common for models, right? So unlike humans, models overwhelmingly make assumptions about a single referent that is the intended referent here. And if they don't, I should say, this is not part of the graph, but whenever you see the green light, basically they almost never ask any clarification question, right? So they would just list the possible alternatives, but not really ask clarification questions. Again, I think this is not so surprising, but it is strikingly different to how humans actually react. Some examples to this question: what color is the bus for this particular image? So some green examples at the top. The buses are red and blue, just listing, right? So you have several listing options at the top. And then for Lava and the other open model here, some less optimal responses, like for instance, the bus in the image is blue, just making an assumption. Okay, it's in the center, I don't know, but it's just making an assumption that is not very warranted, I would say. Or the bus in the foreground is red, also not very clear which is the bus in the foreground exactly. Or simply the bus is blue, okay? Okay, so yeah, I realize I'm kind of a bit slow, so I'll try to speed up a bit. Yes, I should be finishing, right?
Yeah, from promise, I think people might have appointments from 1.
Yes, okay. All right.
We still want to have some food, I guess, and discuss.
Yes, okay, yeah, apologies. I'll wrap up soon. Okay, so the fact that there are no clarification questions asked maybe is not so surprising because of I mentioned before, because of the fine-tuning that these models are exposed to, right? So they assume grounding and therefore they are not really encouraged to ask clarification questions, right? We have some, maybe I will not give you all these examples here, but we have some further experiments with prompting techniques to try to figure out a bit better what are the possible model abilities that go a bit beyond what they would just answer by default, right? So for instance, you may want to encourage the models here by telling them in the prompt, let me know if you need further information to answer the question, right? And if you do that, then you see that the green part increases a little bit, but it's still well beyond the human rates for this, right? And some other types of prompts don't work, right? So for example, in this case, if you add this prompt, this has the right effect. Sometimes it doesn't. Sometimes actually even leads to ask a clarification question, but still the rates in which the models acknowledge ambiguity still remain very low. We can also try chain of thought by telling the model, please explain your reasoning step by step before providing the final answer. Sometimes this leads to acknowledging ambiguity in the reasoning steps, but very often, well, typically they will commit to an answer at the end, to a single referent, and often this referent, so there are no good reasons for committing to a single referent in these images, right? So you can see that, for example, sometimes when the question is just asked in the raw sense, one referent is chosen, while after chain of thought another referent is chosen, but there are no good reasons for choosing one or the other, right? So yeah, it might be acknowledged within the steps, but not in the commits. Some examples. I just want to give you some upshot of the results for the second setting, where we are looking into the social stereotypes, right? So in this case, if we have questions like, what is the person wearing? Then we can see that actually, so that this is not, sorry, so this is an ambiguous question that, an ambiguous question for this image, and GPT-4o in this case actually is able to recognize the ambiguity reasonably well. So it will tell you what the two people are wearing, right? But when we add these tricking adjectives, like what is the sweet or the rational person wearing, then we see that the models have a clear preference for what would be considered the stereotype in this case, right? So this is quite striking, the results on this. So really the models, proprietary or not, they have very strong biases. So there is a clear bias for the social stereotype. So for what is the rational person wearing, then the man will be chosen very overwhelmingly. And what is the sweet person wearing, for example, then the woman would be chosen more overwhelmingly by the models. So yeah, so not recognizing the ambiguity can certainly lead to serious problems. Clearly, I don't have time to talk about this part here, but I would be happy to talk about it later if needed. I will pass over, but it has to do with learning representations for gestures in face-to-face communication, using also speech-language models. I didn't have a lot of details because I just wanted to plug it in, but I will skip it for now. Feel free to look at the paper if you are interested. So let me just sum up. I don't know how much whether I managed to go over these points, but let me just take the upshot of the conclusions. So I try to convey the idea that language use is, at least human language use, is all about exploiting and building common ground, right, between interlocutors. That responding overconfidently, as we see that models often do, goes against the conversational grounding practices that we see in human language use. And then I guess the question that remains open is, how should our methods change so that model behavior becomes more human-like in this respect, right? Is it a matter of adapting the instruction preference learning that is being used at the moment, or do we need something else completely, right? So do we need something that is completely different? Right. So I also wanted to emphasize, maybe I didn't manage so much because there was also more at the end, that yeah, that now that these formal competences of language seem to have been mastered to some extent, is also an exciting moment to look at language in its more ecological ways, right? So to actually try to look at language as a joint action and more at language use beyond formal competences, right? We've seen also that visual grounding by itself is not something that is just going to help us with conversational grounding. It might help us in other ways, but not necessarily in this respect. But it can still be useful, but it's not just going to give us the clues that will help with conversational grounding. But it remains an interesting line of research, of course. And even though we didn't talk about that, multimodality also opens the way for analyzing face-to-face communication in new ways. All right, some work by colleagues that I will leave you here on the slides that I wanted to highlight, and I will just finish by thanking all the people in my group, my collaborators, and you for your attention.
Thank you very much. I would propose, typically we have a general Q&A session now. What I would propose is, given the time, that we maybe, unless there's any very pressing questions, we directly move on to getting some food, and maybe you approach Raquel individually with your questions, because otherwise I'm really afraid people might just run away, and
Sure.
then you know, not only have we all the food here, but also, you know, yeah, you may not have as many people to talk to if we take it much longer. Would that be okay with everyone, or is there any pressing question you really, really would like to ask in a big audience? No. And of course, maybe a quick one. But a really quick
Sure.
one. Jonas, you really have one?
No, it's not a quick one. So.
Yeah.
It's not a quick one, okay.
What I would propose.
2 minutes. So I just. So I think this referential ambiguity study is super interesting. I'm wondering whether it's actually simplifying things in a way that's a bit problematic, because there's never only referential ambiguity, but we also have lexical ambiguity, all kinds of other ambiguities. So we're typically confronted with a situation, one person is feeding the other, but we may not know that what the terms mean. So the trainer is feeding the player. So we're actually at the same time learning what the terms must refer to. And I think the fact that the language models are not kind of so good on your kind of referential ambiguity questions, which really focus on that, is probably not really a bug, but a feature if you're learning this at the same time, the lexical ambiguity. Would you agree?
Well, I mean, so the models are learning all these things at the same time, that's true. But don't you think that the models that we have now should be pretty good at least at kind of entity recognition, right? So like learning at least the mapping between the terms and their reference. I mean, I'm not saying this is trivial because it's not, but okay, yeah, it's true. I mean, the expectation here is that somehow the model should be able to have that solved, right? So that the mapping between the naming of the objects is kind of part of their knowledge, but somehow this idea that something is ambiguous, which I think it has to do with this intended meaning of the questionnaire, seems to be missing. But okay, you're saying, well, probably it's all interleaved.
Yeah, it's probably not a quick question, so we should go into it later, right? So.
Yeah, thanks for your understanding. But I think it really would be good if we move on now. Just before we, first, thank you very much again.
Thanks to you.